Like I was just saying, not much in real life is going to be thrown like this. It's just stupid. Like, no one throws stuff like that. So why are we going to model things like that? However, those questions that you were just looking at, particularly question 5 and question 7, with something sliding along a table, that is going to be a horizontal projection when it gets to the edge of the table. So it's kind of worth thinking about it in that kind of context. I'm going to set you to do 5 and 7 for homework. 7 is interesting. You just need to think slowly and carefully about it. But in real life, most things get projected in this kind of way. So I've said here, components of velocity, just as we split forces into the horizontal and vertical components in order to consider forces in the horizontal and vertical directions respectively, we can do exactly the same thing with velocity. We saw it on that original diagram that we had, the animation. We saw how the horizontals did not change, but the vertical changed according to Suvat that we had there. So I'm going to start off with this bit that we've got down here. I might have said that a tennis ball is projected at 20 degrees, an angle of 20 meters per second at an angle of elevation of 70 degrees. Elevation is things above. This is an angle of elevation. If it was an angle below the horizontal, who thinks, if they know what below the horizontal is called? We have an angle of elevation. Angle of, begins with D.
Delegation.
Depression. So imagine you were stood at the top of a cliff, and if you're like, when you've been to like the seaside and you're on a cliff and you want to throw something downwards, you don't necessarily throw a stone downwards, but you might throw it like out to sea, but you don't throw it up first. So you could throw it downwards at an angle, and that would be called an angle of depression. Most time when you're throwing stuff, like to try and get it in the bin, most of the time you're probably trying to do an angle of elevation. You're going to do the up and then coming down, okay? So this one is 20 meters per second. Very clearly, the horizontal component is going to the right, 20 cos 70, and the vertical is going 20 sine 70 upwards. It must be going to the right and then going upwards. Sufyan, what are you doing? You're going to the right and then going upwards because of the direction that the arrow has here. So you know the directions that the arrows go in as well. A couple of people from the other class found it weird that this was here. You could, of course, move it. So instead of the arrow there, you can see it as the starting point, as it's got an arrow to the right and an arrow going up. You can just literally pick that arrow up and have it drawn out the top if that pleases you to see that. We talked about this earlier on. When the object is at its highest point, what did we say was true when the object was at the highest point? Vertical velocity is equal to 0. What's the horizontal velocity at that point? It's still 20 cos 70. So what's the speed of the particle at the top? 20 cos 70. Okay? So the speed that's the slowest it will ever be is when it's at the top. The speed will increase as it goes down, and you might figure out the speed at a particular point here. Well, at this particular point, you still know it's going across 20 cos 70, and it will be going down some particular speed that you could work out. If you wanted to work out the speed it had at this point here, what do you think you could do with this horizontal and this vertical part? Pythagoras. You could put them together using Pythagoras. And we're going to do a question like that probably on Thursday's lesson. So this little bit down here really should have been in a box, but I've just said we know that the scalar form of velocity is speed, and thus we just find the magnitude of the velocity vector. So for example, here I've got 20 cos 70 and something I didn't know, but if I had a vector of the speed and said it was 12 along and 5 up, and it might have said, what is the speed? Well, you can just do the magnitude, which we know is Pythagoras, and you could say that the overall speed was 13. A little side note that will be coming up again later, so don't worry too much if it seems a bit out of context. We'll be talking about switching between speed and vectors later on, okay? So we're going to dive in, and we are going to do 3 different examples here. That should take us up to the end of the lesson, and then I'm going to set you lots of them to do, and they have to be done for Thursday, because Thursday's lesson is based on everything that we're doing in this. So you're going to need to make sure you find some time. Oh, you've not got any school tomorrow. You've got loads of time.
No, we just had the parents.
Just come in for your individual tutorial. You do need to come with your parents, yeah. Well, let's not talk about this now. So, a particle P is projected from a point O on a horizontal plane with speed 28 meters per second with an angle of elevation of 30 degrees. After projection, the particle moves freely under gravity until it strikes the plane at a point A. And we're going to find various things. So it says it's on a horizontal plane. It says it's being projected from a point O with speed 28 meters per second at an angle of 30 degrees. I insist you draw diagrams for this because the questions that we get to in the future become quite sophisticated. So we know that the pathway this is going to trace out is a parabola like this, and it says it strikes the plane at a point A. So when it hits the plane over here, that's the point that we're calling A that we have right now. We want to find out, first of all, the greatest height above the plane reached by P. So the new thing in this is instead of having the speed, the velocity like this at an angle, we're going to split it into its horizontal and its vertical component. We have 28 cos 30 running along the side, and we have 28 sine 30 running up along like that.
Is mechanics always in degrees?
Yes. Now, as I said before, this arrow, you could think about it as it coming out the top of that. It doesn't have to be over on the other side of the triangle. It's just the way I visualize it. If you want to think about that's its vertical speed over here, and that's its horizontal speed, I don't mind if you draw it in that way, okay? Personally, when I see sine 30, I want to change it. I know sine 30 is a half. So I would probably want to write this as 14. And I know that cos 30 is root 3 over 2, so I'd probably write this as 14 root 3. If you don't, it's not the end of the world. It's just how I work. It's just how I see these things happening. And the first thing we want to work out is the greatest height above the plane reached by P. So we're looking for this height that we've got here. So I'm talking about from this point to this point that we have. Vertical or horizontal? It's got to be vertical, right? Because we're talking about how high it's going up. So considering we're doing this little purple bit, I'll do it in purple. So we're going to look at our vertical motion. Do you want to do upwards as positive or downwards?
Downwards as positive.
Fine, we'll do downwards as positive. If we do downwards as positive, what should you anticipate about your answer for the displacement? Yeah, the maximum height you should imagine getting is negative because it's gone from here upwards. And we've said downwards is positive. So if I get a negative answer, I'm going to be happy, okay? So when you talk about displacement, displacement has a direction. It's imagine taking a picture of it at the beginning and a picture of it when it's its maximum height. It's moved from the bottom to the top. It's moved upwards. But look, over here we've said that we're imagining that downwards is positive. So if I get something that's negative, that indicates that it has moved in the upwards direction. So I want the answer to be negative, okay? So for my vertical motion, I can see that u is equal to, what's the value of u? Minus 14. Now this is probably why I wouldn't have taken this.
Okay, let's change it. Let's say
I think we should change it. Personally, I think we should change it. It doesn't matter, because you're still going to get exactly the same thing. But if we change it and say that upwards is positive, well, then we can just say u is 14. A is going to be what? Okay, good, because we know it's going downwards. So we're going to say minus 9.8. We've switched it to going up. S is the thing that we're looking for. What else do we know? Good. We know that V is equal to 0. Now, when you have just 4 things written, doesn't it become easier to see what equation you should be using? I just know the first one. V squared equals U squared plus 2AS. So 0 equals 14 squared minus 2 times 9.8, which is 19.6 S. So S is equal to 10. So you get 14 squared divided by 19.6, which is 10. So S is 10 meters. What's all this murmuring and stuff going on, boys? Because I don't want to have to re-explain this stuff. This is an important example, right? So S is 10 meters. Now we're going to work out the time of flight. This was my part A. I'm not very good at organising my board.
Find out T of that and then double it.
You could find out the T of that and double it, but I'm going to explore it in a different way, okay? So Rayhan just suggested to find, can I just explain it? To find, because I just want to say something else first, the time of flight, it does exactly what it sounds like. How long has it been flying for? So we're talking about it going from here to here. Now Rayhan said, what did you say, Rayhan?
Just find the T for the super that we just done.
Yep.
And then double it.
So you could find the time from here to here and then double it because we know it's symmetrical. But I just want to point out a different way you could do this because it's the way I like to highlight the power of the Suvat equations where it will just do it all at once. Now, if we're going to consider, again, it's going to be a vertical motion question because I don't really know anything about this at all. Vertically, the displacement, remember how we talk about displacement? Take a picture of it at the beginning, take a picture of it at the end. How has it changed vertically? It hasn't changed at all, so you can just say the displacement is 0. We can say, if we're going to take downwards as, let's do upwards as positive just because to keep matching with what we did before. The acceleration would be minus 9.8. The initial speed would be 14, and we're interested in what the time is. So you get S equals ut plus a half at squared. So you get 0 equals minus 9.8 t minus 4.9 t squared. And then you can factorize, or you can put it on the equation solver. So I can take out t minus 9.8 minus 4.9t. So either t is equal to 0 or t is equal to 2. What's gone wrong here? What have I put in wrong here? Oh, I've put u in. I've not put u in, right? Sorry. U isn't minus 9.8, is it?
No, 14.
U is 14. So when I factorize t, I get 14 minus 4.9t. I knew something was wrong. So t is 0, or how much, Anika? 2.86. Is that 3 significant figures? Now that's weird. It's given me 2 values of time. Why is it giving me 2 values of time?
The displacement is 0 at the start.
At the start, the displacement is 0. At 2.86 seconds, the displacement is 0. What time would it be at the top? Half of that, 1.43, okay? So you could have done Suvat over here and found out t and doubled it. I personally just like to point out this fact that the displacement is 0, reminding you, click, click, photo at the beginning, click, click, photo at the end. It hasn't displaced vertically at all. Last thing we then want to do is the distance OA. What do we need to do for that we haven't done at all yet?
Work out the horizontal.
Horizontal. We're going to consider the horizontal motion, okay? So the distance is the thing that we're looking for. We know that distance equals the speed times time.
28 cos 30.
The horizontal speed is 14 root 3. That's the horizontal speed. And the time is 2.86. And what does that come out as, Anika? How much? 69.3 meters to 3 significant figures. Okay, I'm going to have to go a little bit quick in these next 2 because I need to make sure we get them both done, okay? Ready for the next page?
Yep.
Apologies if we go 3 or 4 minutes over, but we're going to do it, okay? This time we can have things where maybe it's not projected from the ground. We go back to the idea of it being from a cliff. So here we go. Particle is projected from a point O with speed v meters per second at an angle of elevation theta, where tan theta equals 4 over 3. The point O is 42.5 meters above a horizontal plane. So I'm actually going to probably start drawing that bit there. There's the point O, and it's 42.5 meters above a horizontal plane. The particle strikes the plane at a point A 5 seconds after it is projected. So it's being projected with a speed v at an angle theta, and it hits the ground at a point that we're calling A, and the amount of time it took to do that is 5 seconds. They've told us that tan theta is 4 over 3. What do you do when it says tan theta is 4 over 3? You do the triangle. So 4, 3, and there's our 5. So sine theta is, yep, and cos theta is 3 over 5. So, same ideas as before. We resolve the speed. Running along here, running up here. So this one is v cos theta. This one is v sine theta. But we know cos theta is 3/5. So you might like to add to your diagram and say, well, this is just 3/5 v. And this one is just 4/5 v. Or you could have just called it like x and y. You know, you can name them, and later on you can use the factor. I like using them immediately, so the question becomes a bit more simple. And I think we've got everything drawn on the diagram. I suppose the only other thing I probably could have added is 9.8 here. What do we think might be the best thing to consider, the horizontal or the vertical?
Vertical.
Yeah, why? Because we've got the vertical distance.
And we've got the acceleration as well as the
We've got the acceleration and we've got the time. The only thing we don't have is the vertical speed, which we have here. So we can find out what v is. So we're going to start off and we're going to consider the vertical motion. Which way do you want to use? Down positive or up positive? I probably would do down positive because I see I've got a 42.5, I see I've got a 9.8, but it really, really doesn't matter. I'm going to go with down positive. So S is 42.5. A is 9.8. Anything else? Good. U is minus 4/5 v. If you're not sure why it's minus, look, it's being projected upwards, and we've said that downwards is positive. And what else do we know? V is not 0, no. T is 5. When it hits the floor, it doesn't have a speed of 0. It has a speed of 0 after it's hit the floor. When it hits the floor, it has speed, okay? So we'll connect these together using S equals ut plus a half at squared. So S equals this times this, which is minus 4/5 v times v. That's S equals ut plus a half a multiplied by t squared. So this simplifies to 42.5 equals minus 4v plus 122.5 plus 122.5. So rearranging this, 4v equals 80, so v equals 20. What does v equals 20? What is v referring to? No? It's the initial projection speed. It's not referring to the vertical speed. The vertical speed is 4/5 of that. The horizontal speed is 3/5 of that. So just remember all the letters, what they actually represent, okay? Now, we've already considered the vertical motion. We've obviously got to do the horizontal motion, because these questions, if you only do one and not the other, you've failed the question. You will not be successful if you only consider one of them throughout the whole question. So we're going to have a look at horizontal. Please always write what you're doing. Find the distance between O and A. They want the distance between here and here, which Muhi, I think earlier, told us this was Pythagoras. Well, I know this distance, so I obviously have to achieve this distance along the bottom here. So I want to find out what the horizontal distance is. And we know that the horizontal distance is speed times time. Take it all the way back to year 8. The horizontal speed is 3/5 v. So it's 3/5 v times by 5. V is 20, so it just becomes 3/5 times 20 times 5. I should have said, so that's 3/5 times 20 times 5, which is 60 meters. So OA, using Pythagoras, is 60 squared plus 42.5 squared, 73.5 meters to 3 significant figures. We'll easily get the next example done in 5 minutes, and then I can send you away to do all the lovely practice ready for Thursday so we can get on to the tough stuff, even though this is sort of tough. Yeah. Yes, second. We're doing probability. Conditional probability from stats. So we're on stats, yeah. I'm looking forward to it.
I think someone told me last class they finished.
Probability?
Yeah.
I'll take it a bit slower than that. Okay. I'll do 3 lessons on probability. I think they did like 1, and I'm like, no way. We're going to spend a lot of time on probability. We want to make sure we can do it. So if you have finished writing, what I want you to reflect when you look at these questions is how mechanics always breaks down to the same patterns. So a projectiles question is always going to be vertical with suvat, horizontal with speed equals distance over time. That is what these questions are about, and time is the bridging value. Just like forces questions, resolve the forces, F equals ma. Like those are the only things you can do in these topics. So you can try and like simplify what the problem looks like by knowing it's just 2 things that you do. Right, let's have a look at one more with just 2 things that we do here. So a particle is projected from a point O with speed 35 meters per second at an angle of elevation 30 degrees. The particle moves freely under gravity. Find the length of time for which the particle is 15 meters or more above O. So we've got a particle that is being projected like this from O, and it has a speed of 35 and an angle of 30. Find the length of time for which the particle is 15 meters or more above O. Well, I'm just going to guess that 15 meters is probably that kind of high. I don't imagine it's going to be above where it is, because then the question makes no sense. So the 15 meters has got to be somewhere between the ground and its peak part of the flight that we've got there, right? And I want to know how long is it above that time. So I guess really I'm interested to find out when does it get here and when does it get here. So it's going to tell me 2 times when it gets to that particular height. And I guess the way we should think about the times is we know at the beginning it has 0. And I like to think of it as almost like a clock. And as you go through, you're going to get these different times around the clock, right? And to find out how long it is above this particular time, what do you need to do once you find all of the times? How would you find out how long it's above this 15 meters with these 2 times that you have? Ekrim?
It has to be in between.
Yeah, it's the time that's in between these. If it was like a watch and you said, oh, it was, I don't know, 1.2 seconds, and then you had on your watch over here, it said 1.6 seconds, and I said, how long was it up there? You would say, oh, 0.4 seconds. You'd work out the difference between them. So that's what we're going to aim to do. We're going to try and find the difference between these 2 times here, which Hamza correctly said, why don't we call them T1 and T2 that we have? So I better do a bit of resolving. So I'm going to have my 35 cos 30 and my 35 sine 30. What's 35 sine 30? No calculators needed. 17.5, because we just know it's half of 35. Now, this whole question, for me, seems like it's just talking about vertical motion. So I'm going to look at vertical motion. Up or down is positive, do you think? I'm going to go with up, personally, just because we're interested in it being going to 15 meters upwards. So I'm going to set that as my upward direction. Well, I've just said I'm interested when it gets to 15 meters. The acceleration is downwards at 9.8. Anything else? U is 35 sine 30, which is 17.5. And what do I even care about? I want to find out what T is. Now I've got S, A, U, and T, which we know is S equals UT plus a half AT squared. So 15 equals 17.5 T minus 4.9 T squared. It's a quadratic. So you plug it into the calculator.
You get 10 over 7 and 15 over 7.
Thank you. So you get 10 over 7 for T1, and you get 15 over 7. We're going to just do a couple more minutes on this, so sit tight, please, okay? So this means when we get to the clock over here, it's 10 over 7. The clock over here says 15 over 7, and we're not going to finish as soon as I've done this. I need to ask you a couple more questions. So the amount of time, seeing it was 0 here, then 10 over 7, then 15 over 7, the total time above is 15 over 7 minus 10 over 7, which is 5 over 7, which I probably would need to put back into a decimal, which is 0.714 to 3 significant figures. But for the rest of this discussion, I just want to talk to you about the fractions, right? How long do you think it takes to go from here to here?
10 over 7.
Not 15 over 7, it takes 10 over 7. Because to go from here to here, it took 10 over 7. So it must take 10 over 7 to go from over here to over here. How long do you think it takes to go from here to here, to the peak? 12.5 over 7 because, wait, did you say 12.5 over 7? Yeah, 12.5 over 7 because it's halfway between the 10 and the 15, or it's half of the total time. And we can tell what the total time is just from the symmetry, because if that's 10 over 7 and that's 10 over 7, well, 15 over 7 over 10 over 7 is 25 over 7. So you can work out all of these things from the symmetry of what this kind of thing looks like. And you wouldn't need to do SUVAT for these things again and again and again, okay? So I'm going to, this one didn't have any horizontal motion because technically this could have been a year 12 question. Instead of it being projected sideways, it could have just been projected up and down. I'm going to set you a lot of questions on these ready for Thursday. They need to be done for me, okay? Thank you for staying a couple of minutes.